So we're still in the course of Introduction to Engineering. We talked before last time about the qualities of engineers and what kind of properties do the engineers have, what people are expecting from engineers to be. And we discussed a little bit about the importance of engineering as a course. Now, we will talk about the areas of engineering specialization. Each engineering aspect having it is on like kind of a deep level um, course or deep level specialization that would be allocated. Like if you talk about mechanical engineering, while you're studying mechanical engineering, some universities have you have mechanical engineering from day one all the way to graduation, or mechanical engineering technology if you want to be specific, while in other universities, there's mechanical engineering the first year or second year. After the third year, you'll be able to be specialized. Specialized means you go to a deeper level of engineering. Like for mechanical in specific, you could go some, depending on the university and the program. Sometimes you go thermal or fluid systems. Sometimes you go structural or solid mechanics. Sometimes you go aviation. Sometimes you go mechatronics, which is electromechanical systems. For civil engineering, sometimes the same case. So you are be specified either in urban design, like you do housing and things related to housing. Sometimes you could be designing structures for industry, for manufacturing. Sometimes you're designing bridges, sometimes roads, and all of that things. So I want you to know that each engineering term or engineering type have its own specializations. Like when you go mechanical engineering, then you go to that specialization. Let's say in the third, fourth year, you will be specialized in mechatronics. Then when you go to if you are going to mechanical engineering technology, it's different than mechanical engineering in the fact that mechanical engineering will prepare you, as we're gonna discuss moving forward, could be prepared for research and prepared for application in the same time. So as you're moving forward in your higher education, in case you decided to move forward with those, the more you go higher with education, let's say masters and PhD, the more you get specialized. Let's say you got your bachelor mechanical engineering slash mechatronics. Then in your masters you will be robotic design. In PhD you will be the effect of robotic electromechanical systems on the efficiency of factories and so on. So that kind of thing. Each engineering aspect have its own specializations that you can be specialized in. In your case, mechanical engineering technology, let's say you graduate pure mechanical engineering technology, when you go to the market, you can still specialize in the market. Like when you go graduate and you start to apply jobs, now you could be choosing to go automotive industry, you could be choosing to go to aerospace industry, you could be choosing to go to defense industry and all of that stuff. So any industry you move into in your career, that is your specialization, and naturally you will be able to focus more on that, know more about that side of your science that you learned through your engineering degree. Now, there is another thing in mechanical engineering education and engineering education in general called the Abbott Accreditation. Abbott stands for Accredited Board of Engineering and Technology. So in the US, we have 300 colleges and universities that have bachelor degree, which is Abbott accredited. What is Abbott accreditation? That's what we're gonna learn together. So basically, Abbott is an organization being issued by the US and being monitored by kind of governmental side for the education system to make sure we have the quality that we need out of engineers. So if you want to say what does the Abbott accreditation look for, they are trying to go to the department in a certain university. If that department is wishing to be Abbott accredited, then they have these certain qualities. First quality, you need to, your engineers or the engineers who are graduated out of this department or this college need to be able to apply the knowledge of mathematics, science, and engineering. You need to be able to design and be able to conduct experiments. And in the same time, you need to analyze and interpret data. Other thing they focus on design systems, components, or processes so that they meet the desired standards and desired needs. Then engineers are expected to be Abbott accredited out of a certain department to identify, formulate, and solve engineering problems, understand professional and ethical responsibility, and of course, you need to be team members and communicate effectively. And in the same time, you need to be able to focus on engineering solutions for global and society problems that we face today. And engineers who are graduated out of accredited department need to be having the ability to engage in a lifelong learning. As we said, engineer is a lifelong learner, so you always have something to learn. There's always more topics to focus on and learn more about your specific field of study. Then you need to be able to use the techniques and skills and modern engineering tools so that you can use it in applying the science that you learned in the industry or in your field. Why people need Abbott accredited department or university? Abbott accreditation will help you. Let's say you graduated from Abbott accredited university. That will help you as a student or as a graduate to be able to work as a professional engineer. We will see in the coming slides what does professional engineer means. That's one of the needed topics to be a professional engineer certified person. And as well, Abbott accredited allows you, in case you decided to study outside the US, or somebody outside the US, let's say in France, he had his bachelor from Abbott Accredited University, then he can come to the US and finish his education because his university has been certified by a US department or US organization that it is a reliable university. Students or engineers graduating from that university studied in English and been able to apply all the standardized concepts and learning tools so that they can be able to be a good engineers and finish their higher education in the US. We were asking yesterday about if your department is Abbott accredited. So you can see in the website here, I believe you see the laser. So www.abet.org. Try to plug it in your computer right now. I'm going to give you a couple of minutes and identify, is your department as an accredited Abbott accredited department or no. Now, another topic related to Abbott accredited is the PE. PE stands for professional engineers. Probably you saw some of your instructors or professors, especially who holds PhD, they will have like their name, PhD, then comma, PE. PE stands for professional engineers. Mostly you see it in the older professors, if you will. So in 50 states of the US, you need on graduation to register for to be a professional engineer, and to get this professional engineer kind of tag or accreditation or credential, they need to be going through a lot of examinations that are sometimes related to the city. Sometimes there's an organization holding that on behalf of the government to be able to see if you qualify to be a professional engineer or no. But to be able to go through those examinations, you need to get your degree from an Abbott accredited department. That's their first condition. Second condition, be able to pass. There's an 8 hours exam where you need to pass it, testing your knowledge about the mechanical engineering and in your field. And I believe you will not have any problem as long as you learn in the right way. You have no problem in passing that. Then you are a professional engineer. Does that affect you in the industry? Not really, but still, when you are having a PE certification, you can work with the city, you can work with government projects, you can work in many governmental related topics, while other engineers probably they will be less ranked than you in that field. But if you're going to private industry and you're going to private companies, let's say you're going to GM, to Ford, to Toyota, wherever you're going, even in aerospace industry, in aviation and all of that, you shouldn't have a problem not being a PE. Like in the past, people prefer to be working with government because it's a more stable job and there's less possibility to lose your job and you stay there longer and you retire than being in the private industry. This is why some people are having some passion to get their PE certification. Some universities in their programs before graduation, you gotta go through the PE examination. So you'll be naturally PE certified within, like with your degree, with your graduation. So that's about the PE. Now, your program is called Mechanical Engineering Technology. I mentioned about it a little bit earlier. So you have mechanical engineering and you have mechanical engineering technology. Throughout your life, you will be asked by many personnel or many companies what is the difference between mechanical engineering and mechanical engineering technology. The main difference is mechanical engineering is kind of a broader term. The program in bachelor degree will prepare you to be a good engineer in the industry. In the same time, you will get a lot of theoretical part, like you will be focused on equations, how to do a little bit of research, how to do the theoretical part, not only the practical part. So in this case, they are preparing you in case you don't want to go to the industry, you want to go to your master's and PhD. You will have less problems and you'll be more prepared towards your higher education. That's mainly the difference. While engineering technology, it prepares you to go mainly to the industry. You are more, they try to link for you between the theory and the application. Of course, you still get theory. You get 90% of what mechanical engineers are learning, but still, as a technology, considered a plus if you are planning to go to the industry, that you will learn more about how to do your work, how to be more practical, learning about softwares as we're learning with other courses on MATLAB, we're learning in LabVIEW, we're learning Mathematic and all of that. Those, we try to choose programs for you that are being used today in the industry so that when you go to the industry, you don't need a lot of trainings and stuff. You are ready to go and you know what you're doing. So that's the difference between technology and engineering with technology or without technology. Me, I believe personally that even mechanical engineering should have more focus as what the technology engineering is doing. Like all engineers should be ready for the market and prepared, while they have a glimpse if they want to pursue their higher education and research. So for the Abbott, you need the engineers of technology need to be able to learn the followings: appropriate mastery of the knowledge techniques. We already mentioned that. Then you need to apply current knowledges, conduct and analyze and interpret experiments. We already mentioned that. Then you communicate effectively and the whole thing. Now, what are the engineering types? Probably this is something you know. Engineering types are civil engineering, one of the oldest. Then mechanical engineering is the oldest as well, as we mentioned before. Electrical engineering, industrial, chemical, electronics, biomedical. And it's worth to mention that as we're moving forward and there's new technologies and new applications of science, we could have in the future, like let's say astronomical engineering, I don't know, whatever it works for that time, kind of, like engineering topics and engineering types are moving and changing along the time based on the need of the market and the need of the communities. Now, if we want to talk about you as an engineer, how does education go for engineers? You go from high school to college. There is only 5% of students who graduate with a bachelor degree are engineers. So you are the elite students. You are the kind of the top five, the best of the best, if you will. Only 5% of graduates in bachelor degree are engineers. So the market needs you more than what is available jobs. So there's always a lot of jobs, a lot of opportunities for you. Then it's known as an engineer studying, you need to be able to have time management. You need to allocate time for the serious stuff and for the fun stuff. There's a lot of students who get dragged into studying only and they think they will do great, but still never ignore the fun part because otherwise you'll not be able to keep a good well-being and you'll not be able to relieve the stress that you get from working all the time. Then for studying, you need, of course, it's generic advice. You need to keep up with your study load and try not to accumulate, even though that happens more frequently. And it's suggested for you to be part of groups in terms of activities. Try to collaborate, try to be part of a groups. There's many engineering groups for students and for graduates and even for future engineers that you can be part of and those guys are having the same mentality as you and the same goals as you. So it's always a good thing to be around these and you learn from them and learn from you. And that builds your personality towards the industry and your future. Now, as an engineering student, what is your characteristics? That doesn't apply to everybody, but in most cases, usually engineering students are interested in mathematics and science back in high school. You are expected to be thinking in a logical manner. Then you are able to draw conclusions for the problem solutions, and you always have a higher rank of curiosity. Then you have passion for helping solving the daily problems and challenges. If you don't have some of those, that's normal. Not everybody have everything, but as you're moving in the program, you'll be more and more getting those without you realizing. Now, engineering sciences versus engineering specialty, as you can see in the graph, versus the other topics, fields of science. For engineering sciences, electrical sciences, material mechanics, that's 16% of the total sciences been allocated and having students or people studying in that field. There's engineering specialty taking 26%. As you can see, engineering is taking a big portion of the total number of sciences that people are interested in because the demand of the market is higher than the others. Then there's people in business 3%, mathematics 15%, introduction to engineering like graphics and computer graphics 6%. It's considered to be a kind of a private portion of engineering. Then for communication 8%, and so on. Now, for engineering professionalism, again, we mentioned that before. As an engineer, you're expected to be having special knowledge and skills in your field. You are supposed to be working honestly with other people and always having the honesty as your tag. Then you are having interest in professional advancement. You are always willing to take your current position to a higher level and be able to help a bigger portion of the community and so on. Then, of course, whenever needed, you are able to support professional societies and be able to support communities in their current and future problems. Now, let's leave you here with a scientific reading. I don't want you to take this home, so I'm gonna give you 5 to 7 minutes so that you can do your scientific reading. We have here four websites. The first one is for National Science Foundation. The second one is for Jet Propulsion Lab. And the third one is for the US Patent and Trademark Office. The fourth one is for the National Society of Professional Engineers. I want you to look either into all of those or some of those, scan through them quickly, and tell me things that you never knew about engineering. Like some of these, they have kind of a headlines and news. You could find a new type of engineering that you never heard of before, a new machine that's related to engineering that you never heard of before. I believe we almost here concluded. So we're gonna share with you the micro project. So I'm expecting to you to compile a list of products and services that are not available now that you think it's gonna be available in the next 50 years.